13.1 Pythagorean Theorem. This is the first unit in Module 13, which is all about the Pythagorean Theorem and triangles. Our objectives for today are that I can solve problems using the Pythagorean Theorem and that I can identify right triangles. So, first thing, we've got some vocabulary. The first vocab word is leg, and this is the side of a triangle forming a right angle. That's the key there. It's the two sides that form the right angle. It is attached to the right angle. And when you start talking about attached, you start getting into the mindset of some of our trigonometry ratios that you could learn about in future math classes, sine, cosine, and tangent. But the important thing to know is the leg is the one that is attached to the right angle. It is part of the right angle. The hypotenuse is the side of the triangle that is opposite the right angle. It is also going to be the longest side. So hypotenuse is the longest of the two words. That means, or that is just kind of a reminder that it is the longest of the two sides as well. So what is the Pythagorean theorem? In words, it's any right triangle, the sum of the squares of the lengths of the legs is equal to the square of the length of the hypotenuse. In other words, a squared plus b squared is equal to c squared, where a and b are your two legs, right? They make up your right angle. And your hypotenuse is C, the longest of the two sides. And if you were to fold those up, you could see clearly that the hypotenuse is the longest of the two sides, three sides. So let's go ahead and use this. We're going to first find a hypotenuse. So we know that this is A, this is B, this is C. So we're trying to find C. So it's A squared plus b squared equals c squared. So the first step, a is 3, so we substitute in that and square it. B is 4, and we square it, and that's equal to c squared. 3 squared is 9, 4 squared is 16, and that equals c squared. And combine like terms, 9 plus 16 is 25, is equal to c squared, so the square root of that is going to be 5 is equal to c. Now, we're only going to be looking at the principal roots on these, so that is the positive root, positive square root of these values, because right, -5 could be a value as well that would give us positive 25. However, we look at the positive values in the context of Pythagorean theorem because we are looking at a physical object, and the negative value does not make sense in the context of the question. All right, and we don't have any units given to us, so that we can't add anything to our problem. We can't say 5 inches or 5 feet, 5 miles, or whatever it may be, because there's no units given to us. All right, let's take a look at letter B. We have sides 2 and 7. So we have that's our A, that's our B, that's our C that we're trying to find. So A squared, 2 squared, plus B squared, 7 squared, equals c squared. We don't know what c is yet. So 2 squared is 4. 7 squared is 49, equals c squared. I can already see that this is not going to give me a perfect square. 53 is not a perfect square. So we're going to take the square root of both sides anyways. You will need to use your calculator on this. So when we take the square root of 53, you are going to get that it is going to be these, so it is going to be 7.28 approximately is equal to c. So about 7.28. We'll use the squiggle equal sign because we are rounding here. Right, 7.28. If you rounded it to the nearest tenth, it'd be 7.3. My tendency in these is to round to the nearest hundredth place. You can have future math teachers or science teachers teach you about significant figures and appropriate places to round. But for us, hundredth place is pretty solid. All right, I'd like you to try letters C and D on your own and then check your work against mine. All right, letter C. We've got our sides. So we've got A, B, and C. So we have 4 squared plus 8 squared is equal to c squared. Now, 4 squared is 16, 8 squared is 64, and that's equal to c squared. 16 plus 64 is going to give us 80. 64, 74, 80. So 80 is equal to c squared. And when we take the square root of 80, we're going to get 8.94 is approximately equal to c. So we're rounding that off. It would be 8.944271191. So we're just going to round it off to 8.94. All right, letter D. We're going to go ahead and get started here. We've got our A, our B, and our C. So A squared, we've got 12 squared, plus our B value, 18 squared, is equal to C squared. Now, 12 squared is 144. 18 squared, you probably don't have that one memorized. It's 324. And when you add those two values together, you get 468 is equal to c squared. And so now we're going to take the square root of 468. And when you take the square root of 468, you are going to get 21.63 is approximately equal to c. Now, when you're typing your answer in, you could just type in the equal sign, that's fine. Or you could just type in the value. That's also fine. Okay. All right, so let's take a look at our next page. Now, instead of finding the hypotenuse, we already know what the hypotenuse is, and we need to find the length of one of the legs for these questions. So let's take a look at letter A. We know we've got an A, we've got a B, and we've got C. So A squared plus B squared is C squared. So 5 squared plus, we don't know what B is, so that's going to be x squared, equals our c squared, which is 13 squared. So 5 squared is 25, x squared is x squared, and 13 squared is 169. All right, so now we're trying to find x squared, so the first thing we need to do, subtract 25 from both sides. And we get that x squared is equal to 144. And the square root of both sides of this, x is going to be equal to, we know that number is 12. Square root of 144 is 12. All right, let's look at letter B. We have our A value, our B value, and our C value. Now, do A and B have to be those exact sides? No, they could be switched. B could be x and A could be 10. Either way, they're both a leg. That's what really matters here. All right, so our A value, A, we don't know what it is, so it's x squared, plus our B value, 10 squared, equals our C value, 23 squared. So x squared is still x squared, 10 squared is 100, and 23 squared is going to be 529. We're going to subtract 100 from both sides. We get x squared equals 429, and then we're going to square root 429, and we are going to get that x is equal to 20.71 approximately. Right? The full decimal would be 20.71231518, and keeps going on from there because it's an irrational number. All right. You go ahead and try letters C and D on your own, and then check your work against mine. All right, letter C. We've got our A value, our B value, and our C value. So A squared, so we've got 9 squared plus x squared equals 15 squared. 9 squared is 81 plus x squared equals 225. We're going to subtract 81 from both sides. X squared is going to be equal to 144, which we know from the problem A, when we take the square root of it, 144 is 12. Square root of 144 is 12. All right, letter D. We have an A value is unknown, B value is 6, and our C value is 19. So our unknown x squared plus 6 squared equals 19 squared. 6 squared is 36, and 19 squared, again, one you probably don't have one in your memory right away, is 361, and it's not squared, it's just 361 because we already squared it. All right, so now we subtract 36 from both sides, and we get x squared is equal to 325. Take the square root of both sides, and x is going to be equal to approximately 18.03. All right. So now we're going to talk about identifying right triangles, the second half of our objective for the day. And we have this thing called the converse of the Pythagorean Theorem. And it states that if a triangle has side lengths of A, B, and C, and A squared plus B squared is equal to C squared, then the triangle is a right triangle with a hypotenuse of length C. So if you substitute the three values into the equation and it is true, it is a right angle. It is a right triangle. So let's substitute in, let's see what we get. So we look at our three sides for letter A. A and B don't matter, but C must be my longest side. So we're just going to do them in order, A, B, and C. So we have 2.1 squared plus 7.2 squared equals 7.5 squared. All right, 2.1 squared. 2.1 times 2.1 is 4.41. 7.2 squared is 51.84, and 7.5 squared is 56.25. Combine like terms on your left side of the equal sign. 4.41 plus 51.84, you get 56.25. And that does equal 56.25. So is this a right triangle? Yes. It is a right triangle, right? So you just have to prove that they are equal. All right, let's look at letter B. We've got 5, 8, and 10. So there's our A, there's our B, there's our C. We can't always assume that the drawing is going to be drawn to scale. So again, you do need to look at the fact that your C value will always be the longest side on your triangle. And this, in this case, it is 10. It does visually look like the longest side, but sometimes you will have deceivingly drawn pictures that may not be showing you the exact ratio or exact proportions correctly. So just do keep that in mind. You do have to always pay attention to it. So we do 5 squared plus 8 squared equals 10 squared. All right, 5 squared is 25. 8 squared is 64. That is equal to 10 squared, which is 100. Combine like terms on the left. 25 plus 64 is 89, which is equal to 100. It's not equal to 100, so this is not a right triangle. So it's not right. Okay. All right. On the next page, I'd like you to do letters C and D on your own. You're given, again, just the numerical values of the sides. Your hypotenuse will always be the longest of the sides. All right, letter C. If we look at it, we need to identify our A value, our B value, and our C value. 52 is the longest side. So we have 20 squared plus 47 squared equals 52 squared. All right, now when we are working with this, 20 squared is 400. 47 squared, definitely not one that you have in your memory banks already. It is 2209, and that's going to be equal to 57 or 52 squared, which is 2704. Now, you add these two values together. 2209 plus 400 is 2609, which is not equal to 2704. So it's not right. Okay. Now, if we look at letter D, again, we're going to label A, B, and C values. And for letter D, 9 squared plus 40 squared equals 41 squared. 9 squared is 81. 40 squared is 1600. 41 squared is 1681. And it's pretty obvious already, but you can see this 1600 plus 81 is 1681, which is equal to 1681. So this is a right triangle. So it's not enough to just say they're equal. You do need to declare what does that being equal mean in the context of the problem. And in this case, it is that it is a right triangle specifically. All right. Now, problem 4 is the distance formula. And this is the application, or this is an application of the Pythagorean theorem. So you can use the Pythagorean theorem to find the distance between 2 points on a coordinate plane. The rise and the run of the points will give you the legs, and the distance between the 2 points will be the hypotenuse. So rise over run, we think of that in the context of slope. It's how much it goes up and how much it goes to the right, or how much it goes down and how much it goes to the right. So let's look at letter A, right? If we're going to use this, we've got the coordinate plane, and you can see that forms a right angle right there. So the amount we're going up, 1, 2, 3, 4. The amount to the right, 1, 2, 3. All right, so now we're going to just do that math. We have a triangle here. We've got, so our unknown, our x, so x squared is going to be equal to 4 squared plus 3 squared. Okay. Our unknown, our hypotenuse, is equal to 16 plus 9. 16 plus 9 is 25. And when you take the square root of both sides, you get x is equal to 5 units. Okay, so there's a whole distance formula that we could use, but we didn't because we were given a graph, right? And so this is kind of showing us the mathematical or the spatial aspect of this. And then we're going to work on the mathematical one in letter C. But right now, spatially, we can see how much we are going up and how much we're going to the right. Those are our two side lengths. All right, so now letter B, I'm going to bridge the gap a little bit between the formula, the distance is equal to the square root of the quantity x2 minus x1 squared plus the quantity y2 minus y1 squared. So let's look at this. Let's just start labeling x1 and y1. So we have x1, y1, x2, y2. All right, so we're going to look at this in a couple different contexts. First off, what are my coordinates for these points? Well, x1, y1, that is at 5, 4. And x2, y2, that's going to be at 2, negative 3. So if I want to know what x2 minus x1 is, that's how much we're moving to the right. x2, negative 2, minus x1, 5, positive 2. Our parentheses ended up being a little wonky there. So that was positive 2 and negative 3. So if we've got 2 minus 5, x2 minus x1, 2 minus 5 is negative 3, right? Negative 3 squared is 9. We're going 1, 2, 3 spaces over, right? So that's where that x2 minus x1 is. So that's that negative 3 squared. How much are we going up? We're going up 1, 2, 3, 4, 5, 6, 7. And when we look at that, negative 3 minus 4, gives me negative 7, which is then going to be squared, right? So depending on which point you use, you may get a negative value here, but you're squaring it, which becomes a positive value. So now we have our two side lengths, 3 and 7. So let's just use Pythagorean theorem. 3 squared plus 7 squared is equal to x squared, our unknown. So 3 squared is 9, 7 squared is 49, and that's equal to x squared. Add them together, you get 58 is equal to x squared, and then you need to take the square root of both sides here. And the square root of 58 is 7.62, and that's equal to x. And again, we don't have any context for these problems, so there are no units that we can attach to them. In your assignments today, you will have some questions that are giving you a real-world context, and you will have some units that you're going to work with. So you'll just have to pay attention to those. All right, letter C, let's just use the formula now, the distance formula, x2 minus x1, the quantity squared, plus y2 minus y1, the quantity squared. So x1, y1, x2, y2. All right, so it's just in the order that the problem is written. So distance is equal to the square root x2 minus x1. So 5 minus 3, the quantity squared, plus y2, 4, minus y1, negative 2, the quantity squared. So distance is equal to 5 minus 3 is 2 squared. We went 2 to the right. And 4 minus negative 2 is 6 squared. We went up 6. So our distance formula, we've got the square root. 2 squared is 4. 6 squared is 36. Add those two together. That's the square root of 40, which when you use your calculator, you get that the distance is equal to, not the square root anymore because we're taking the square root. The square root of 40 is going to be 6.32 when you round it to the hundredths place. All right. Letters D, E, and F are yours to choose or to do on your own. Check your answers against mine. So letter D, we're given a graph, so we don't need to use the formula, but we can use the fact that we know we have a right angle here. We're going 1, 2, 3, 4, 5 steps down. 1, 2, 3, 4, 5, 6, 7 steps to the right. So we have 5 squared plus 7 squared equals x squared. 5 squared is 25. 7 squared is 49 equals x squared. 25 plus 49 is going to be 74 equals x squared. And we're going to take the square root of that. And the square root of 74 is going to be 8.60 is equal to x. Okay. All right, letter E. We're going to use the distance formula for this one. So distance is equal to, I'm going to just put a 1 and a 2. 1 and 1, 2 and 2. Right, because we know which one's x, which one's y. So our square root of x2, 8, minus x1, 1, quantity squared, plus y2, 3, minus y1, negative 5, squared. So our distance is equal to the square root of 8 minus 1 is 7 squared. 3 minus negative 5 is 8 squared. So our distance is equal to the square root of 49 plus 64. And 49 plus 64 is 113, which we need to take the square root of. Our distance is equal to 10.63. All right, last one for today. Our distance formula. Distance is equal to the square root. And again, I'm going to just write 1 and 2. We know which one is x. We know which one is y. So we have 3 minus -5, the quantity squared. And we have -2 minus 7, the quantity squared. So our distance is equal to the square root. 3 minus -5 is a positive 8 squared. -2 minus 7 is -9 squared. All right, and now we need to square those values. So 8 squared is 64. -9 squared is 81. Add them together, combine like terms, you get 145 still inside the radical. And then when we take the square root of this, square root of 145 gets us 12.04. All right, those are our notes for today. If you have any questions, please bring them to class tomorrow. Otherwise, I hope you have a great day.